Alright, good morning everybody. I'm sorry that I'm not able to make it into school today. I woke up this morning feeling horribly sick, but I didn't want you guys to lose out on some good time to get some intervention here, so I'm going to go through a little video on teaching what I was going to do today, and then after this, we'll go through this a little bit more tomorrow once I am hopefully back, and we'll do some practice on this tomorrow during Pioneer time then to make sure that you've got this stuff down and that I can give you as much help as we need. So for today, we're going to be talking about how to write a good explanation. So the biggest problem that all of our geometry teachers see with the Solve Explain standard across all of our classes is that people don't tend to know how to write a good explanation. One thing that I've talked about a lot with my classes is the how to solve an equation versus why you set up the equation. A lot of people tend to write the how they solve the equation. It does the algebra. They talk about, well, first I subtracted this on both sides, and then I divided, and then I got this answer and I plugged it back in. Those are steps on how you solved. But one thing you're going to notice in all the problems we're going to have today that we're going to work with and tomorrow, and also all of the problems that will show up on your tests, quizzes for Solve Explain, they're not going to ask you how you solve, they're going to ask you why you set up the equation. So I'm going to give you a few steps here, some things that you should do for each Solve Explain problem. These things are going to help you to be able to write a good explanation. It's going to explain everything that we want to see on a test, on a quiz, on an assignment. When we give you a Solve Explain problem, this is going to help you to do the explain part really well. We'll talk a little bit about the solving as well in the middle of this, but we're going to focus mostly on the explaining part here, so that way we've got that explained down, because most people seem to be doing pretty well at the actual solving of problems. So there's four main steps that we're going to talk about while we go through this. Step number one, the first thing that you should do with every problem is to find out what you are solving for. So this might seem like a really basic thing to figure out what you're solving for, but it's a really good idea whenever you're doing a Solve Explain problem to read whatever the problem is and underline some of the important information. Find out what exactly are you solving for. Does it want you to find a value of x? Does it want you to find the length of a segment? Does it want you to find the measure of an angle? Does it want you to take that x and plug it back in, or are we just stopping with that x value? What units should be on your answer based on what you're trying to solve for. There's a lot of good clues that can come out of just looking at the problem and finding out what you're actually trying to solve for. Next up, based on what you're solving for, you're going to find what properties, theorems, or postulates you might use. So find out what things you would need to use to solve for the thing it's asking for. Based on what we've worked with, this is writing down the name of a theorem, the name of a postulate, or maybe the name of a property that we've learned about, a vocabulary word. Something like that that is going to be the main thing that you're using to solve. Now, after you've figured out what you're solving for and what thing you're going to use to help you solve, the next thing that you might want to write down, maybe as a note on the side of your paper for each of these problems, is are there any relevant vocab words that I might want to use? So in your explanation, you should include more than just the theorem or the postulate that you use. So just for an example, before we actually see a problem here, if we were doing a problem that used alternate interior angles from our last unit that we just did. That's the name of a theorem that you would use to solve a problem. That's great to have in your explain. But what does that actually tell you? Another vocab word that's related to that is saying that those angles are congruent. Congruent is a vocab word that would be very good to include in your explain because it tells me that you know more than just the name of the theorem. You know what that theorem means. And finally, after you've done all of that, you're going to write your explanation using the property, theorem, or postulate. I'm just going to write theorem here. And any other vocab words that you said that we should use. Vocab. So you should write your explanation that uses both. When you write your explain, it doesn't have to be long. It doesn't have to be a whole paragraph for every problem. It can be as short as a sentence. But that sentence should include whatever theorem, postulate, property that you're using to solve. And it should use any vocab words related to that. Words like supplementary, congruent, perpendicular, angles, things like that. Making sure you describe what that actual theorem or postulate says and does, using something else to help supplement than just not spitting the theorem at me and saying, I solved this using whatever the theorem is. Tell me a little bit more. If you do all of these steps, you should have a great explanation that you can use to solve any problem that we might throw at you. So we're going to go through here a few examples of some problems, one from Unit 1 and one from Unit 2, where we're going to talk through how do we write the explanation. So for example 1, we're going to go back to, or example A, we're going to go back to Unit 1, where we're going to be working with some segment addition here. So notice this is a problem that we've seen a bunch of times where we're adding some segments together to make a larger segment. Now, following our steps that we just put on our bullet point list up above this, our first thing was to figure out what it is we're solving for. So reading my statement, it says find the measure of AB, explain why you set up the equation you used to solve. Now the part that says what I'm solving for is this part right here. It wants the measure of AB. Now what is AB? Looking at my problem, AB is a segment. So I want the measure of a segment. That's what I'm going to be solving for here. So that's step 1, was figure out what I'm solving for. That's AB. Now step 2 is to figure out what postulate, theorem, property that I'm going to use to solve this problem. Well, if I'm trying to solve a problem where I'm looking for the length of a segment, back in Unit 1, the name that we gave for solving for segments was called the segment addition postulate. So this is why I said you might use things like theorems, postulates, or properties. This time we're going to use a postulate called the segment addition postulate. This is the name of the main tool that we're going to use to actually solve this equation. Excuse me. Now, our third step was to find any other vocab or any other useful information that would be good to include other than just the name of the postulate. Now here, there's no other good vocab words to use besides just segment here, but what we want to include in our explanation is what does the segment addition postulate say? If we include that, that's going to help us to write a very good explanation. So looking at our diagram, let's take a look and see what does the segment addition postulate say. We know that that says that if we add the two smaller segments together, their length will be equal to the whole larger segment. So taking a look at what we have here, our largest segment is this one right here. It is the one that goes all the way across. It's this x plus 28. That's my whole segment. The other two, AB and BC, those are going to be my two parts of a segment. So what my segment addition postulate's telling me in this problem is that if I do segment AB, one of the parts, plus segment BC, the other smaller part, it's going to equal the length of segment AC, that one that's on the bottom. So my two pieces of information that I need to write this explanation is the name of the postulate I'm using, the segment addition postulate, and the specifics. What does that say? That's this part right here. That's what the segment addition postulate actually says. So let's write the explanation here before we even actually set up any equation, because we can do that. We know how we're going to solve the problem already. We already wrote it out, so let's write out the explanation before we even do the solve. That way we don't forget to do the explanation, because some people do that. They solve it and then they move on to the next one and forget to do the explain. If you do the explain first, it'll tell you how to set up and how to solve, so that way you won't forget it. So our explanation, this is a good way to lay this out. Since we know we want to solve for AB, let's start by saying that in our explanation. To solve for AB, next we're going to talk about what are we going to use. We will use the segment addition postulate. And now our last part of our explain, I want to put what does the segment addition postulate say? So this says AB plus BC is equal to AC. So in my explanation here, I've got all three of my steps that I talked about. My first step in my explanation is to say what it is that I'm solving for. So I said to solve for AB. I started by talking about what am I actually doing. My second step in my explanation is to say what am I going to use to solve. So I said we used the segment addition postulate. That's what I used. And now the final part of the explain is what does that say? So I said it says AB and BC make AC when you add them together. So the three parts of my explain are to say what am I solving for, what am I using to solve for it, and what does that theorem or postulate say that we get to do. This is one sentence as an explanation, and it goes over everything that we need to know to be able to explain and set up and solve this equation. Now, to save on a little bit of time, I'm not going to go through all the steps of actually solving the equation, but because we have our explanation, I'm going to show you how do we write our equation. Well, we know AB plus BC equals AC, so let's substitute in to that equation all the values from our picture. We know AB is equal to 2x plus 35, that was AB. BC is just 5, and AC is x plus 28. Because I already wrote my explanation and I wrote down what it tells me about the problem, now I already have my equation written. I don't have to guess on what I'm going to be doing because I already wrote out my equation using the names of the segments. All I had to do was plug in the numbers, and from here this should be a pretty easy algebra solve from here. I'm not going to go through it here now. We'll get some more practice at that later because right now I just want to focus on how do we do the explanation? How do we actually explain these problems? So that's how we would do one of these using our information that we learned in Unit 1. Our angle addition problems from Unit 1 will be very similar. Instead of saying segment addition postulate, we'll say angle addition postulate, and we'll show which angles we would add together. So it's the same idea, just using angles instead of segments. Now, our final example that we're going to go through here is going to be one that uses some information from Unit 2. Now here we're using information that we learned about parallel lines with a transversal. Things like vertical angles, linear pairs, alternate interior angles, all of those kinds of things. So we're going to go through the exact same steps we just did. So let's go through those 3 steps before we write our explain. Step number 1, figure out what we're solving for. By reading the question, it says find the measure of both angles. This is an important piece of information. It doesn't just want us to find one angle, it wants us to find both. So we know we're going to have to plug back into 2 different things. We need to make sure we know the measurement of both of the angles, not just one. So reading through that and circling that reminds me that I'm solving for not just one thing, I'm solving for 2. Next up, we're going to figure out what we're going to use to help solve for these. So let's take a look at our picture and see what theorem, postulate, property we might use. Now looking at this picture, I've got to figure out what are those 2 angles that I see, how are they related? In this picture, my angles are here and here, and those 2 angles, because they are directly across from each other, they're across this intersection of lines, that means that these 2 angles are vertical angles. So my theorem, my property that I'm using here is what I know about vertical angles. So the way I'm going to set up and solve this is going to use that. Step 3 is to figure out what do vertical angles tell me? What does that mean? Well, we know that vertical angles are always congruent to one another. So what that means in terms of an equation is that we know that their values are equal. So we can say that either way, saying that they are congruent is the same thing as saying that their values are equal to each other. So that's some good vocabulary that we can use in our explanation to make sure that we write a really good one. Because we're going to talk about how those angles are congruent, and that means that I can set their measures equal to one another. That's knowing what it means to be congruent angles. So now let's go ahead and write our explanation for this problem. So again, we're going to start out by saying, what are we solving for? So to solve for the measure of both angles. Now, what are we using? We will use the property of vertical angles. And now what do we know about vertical angles? They are congruent. Now what does it mean to be congruent angles? This means that their measures are equal to each other. So let's break this down again just to take a look at our parts that we have. So, what are we solving for? We are solving for the measure of both of the angles. That's my step 1. Step 2, what are we using? We're going to use the property of vertical angles. What is that property? What do we know about vertical angles? They are congruent to each other, and that means that their measures are equal. Now, when I go to actually set up my equation, that means that I know that those 2 things are equal, so I would put 13 plus 5x is equal to 7x minus 3, and from there I would solve. So again, going through this in my steps, I'm not going to worry about solving right now, but again, what I'm looking for is for you to write out what it is you're solving for, what property are you using to solve, and what does that property say about what we're solving for. If you include those 3 steps into every explanation that you do, your explain is sure to be very good and will definitely get you points as long as you pick the right properties to use. But if you go through this step by step, you'll be able to write very good explanations that are going to be able to do well for you on quizzes and tests. Again, I'm sorry that I can't be with you guys today. I hope that this was helpful. I'm going to go through this a little bit more tomorrow once I come back for our Pioneer time. Then I'll do a little bit of a recap just so that way if you missed something today, you can get caught up on that tomorrow. And we'll work through the backside of this page tomorrow as practice so that you guys can practice doing some of this writing. So I hope you have a great rest of your day, and I will see you all tomorrow.